Okay, everyone, I'm back with the second half of these quantum numbers. And so now I'm looking at the long version of the electron configuration so that we can actually make different diagrams. You can see these are very different from a Bohr-Rutherford or a Lewis dot, but they are actually better in that they show us all four quantum numbers represented pictorially. So right now, if I look at carbon here, so there's carbon on our periodic table. It's just kind of a gross diagram of the periodic table, but it has all the orbitals and everything kind of laid out. So carbon's located here, so it's in the 2p orbital. That's where it finishes filling its electrons. So I write 2p, and then I work backwards from carbon. So the next one behind it is 2s, and then I work up from there, and the next one is the 1s orbital. So that's how it starts out. And then I get the subshells. So in that one, there's only one subshell. And same with the 2s orbital, one subshell. And then I get to the p orbital, and we know there are three, so I put 3 circles. And then we know there's a total of 6 electrons in carbon. So we have to fill, based on the rules of the lowest energy level gets filled first until we run out of electrons. So the lowest energy is the 1s. So I put 2 electrons in there, and once it has 2, the s orbital is filled. Notice I'm putting arrows going in opposite directions. Those are representing spin. The circle represents the subshell. The s is the secondary number, and the first is the primary number here. So as we move on, we still have 4 electrons left, so we move to the 2s orbital. We fill that one as well. It can only hold 2, so we have 2 left. So now I put them in this last orbital of the 2p, and notice that I don't pair them up because you have to fill all your subshells first before you go back and pair them up. So if I look at, say, tellurium, and I have picked that because, well, I randomly chose it before. And so if I go back and look at tellurium, here it is. It's hanging out right here on the periodic table. So how many levels is it down? Well, it's 5 levels down, 5 energy levels down. And this area on the periodic table, this is the p orbital area. So if I go back and show you, see, here's the p orbitals are all in this area. So it is in the 5p orbital where it ends, and then it works its way back. So 5p, when we go over here, this area is the d orbital, and the d orbitals are always one number less. So if you look, if I'm in the 6p here, I go to 5d. So with tellurium, I'm in the 5p, so the next one is 4d, and then I keep working back 5s, and then I go up. So up and over. So 4p, 3d, 4s, up and over, 3p, 3s, up and over, 2p, 2s, and then finally into the 1s orbital. So when you look at tellurium here, I can show you the 5p is where it ends, and then 4d, 5s, and so on, all the way down to the 1s orbital. Notice all of these energy levels are filled with electrons except for the very last one, which is the 5p. And in the 5p, I had 4 electrons left, and so I spread them out. Notice these ones don't pair up because I don't have any extras to pair, and I have to fill each subshell first. So how did I know that there were 4 left there? Again, I look at the periodic table and where tellurium is located. In the p orbitals, I count over 1, 2, 3, 4. So it has 4 electrons in that final outside shell. So that's how I figured out my electron configuration. Now the short form for it, you can see, is right beside it. And the way I figure out the short form is I go to the first 5s I come across, working my way down. I draw a line under it, and everything underneath that is the same as the noble gas that's just one row above. So in this case, it's the krypton. So anyways, what I am left with is the 5s orbital with 2 electrons. So that's why it says 5s2. The 4d orbital, and it has 10 electrons. So 4d10. And then the 5p orbital with 4 electrons. So 5p4. So it's saying everything is the same as krypton with these few extra changes. So now that I've showed you that, you can practice a few. So you've got phosphorus, manganese, bromine you can try, mercury, and then finally these 4, fluorine, vanadium, xenon, and nobelium. All right. Enjoy, everyone, and I'll talk to you again.